Let us build one more machine learning project using BootML. Say we have to build a model which predicts the burned area of forest fires in northeast region of Portugal by using meteorological and other data. The dataset contains various features like month, day, temperature, and wind. Our algorithm should learn from this data and build the model. Then this model should be able to predict the area burnt by forest fire, given all other features. Here, column X and Y contain the x-axis and y-axis spatial coordinates respectively within the Montesino Park map. Month and day column represent the month of the year and day of the week respectively. FFMC, DMC, DC, and ISI column contains the corresponding indexes from the fire weather index system. TEMP column contains the temperature in Celsius degrees. RH column records the relative humidity in percentage. Wind column contains the wind speed in km per hour. Rain column contains the outside rain in millimeter per square meter. And the area column contains the burned area of the forest in hectares. For the detailed description of dataset, please check the link displayed on the screen. This dataset is already part of BootML. Let's train the model. Open BootML. Create a new project and name it as Forest Fires. Click on Next. The problem is a supervised learning regression task. And as we know, the root mean square error is the preferred performance measure for regression tasks. Next, we select the existing forest fires dataset and then select the forestfires.csv file and specify the file type as CSV. Let's move to the next step. Click on See Your Data here to see the first few rows of the data. Next, discard the columns which you think are not required for this training. And then, select Features and Label. Here, the label is Area and all other columns are Features. Move to the next step. We plan to split the data into training and test set in 80-20 ratio. Specify the random seed as 42. You could specify any other random seed. Afterwards, select the columns for scatter plot and check the Generate Correlation and Scatter Matrix checkboxes. Next, select median as an imputer for fixing the missing values. Move next. Specify numeric and categorical fields. Click on See Your Data here to see the data. As you can see, only month and day columns are categorical. Move them to categorical field column. In this step, scale all the columns using standardization. Move next. In this step, specify the number of crossfold as 10 and train 3 different models using linear regression, random forest, and decision tree algorithms. Tune the hyperparameters using grid search algorithm. Click on Next. In this step, generate the notebook. Open the notebook and run all the cells to see the result. Now, let us walk through the data and the project notebook to understand in more details. Here is the dataset location and the file name is forestfires.csv. The dataset has a total of 13 columns and 517 rows. Here, we can see the mean, standard deviation, minimum, first quartile, second quartile, third quartile, and maximum of all the columns. Here, we split the data into 80-20 ratio with random seed of 42. Here we can see how the area is correlated with other features. The area has positive correlation with DMC and TEMP features, and negative correlation with RH and RAIN features. Next, we fix the missing values with median and separate the numerical and categorical features. Then we apply one hot encoding in categorical columns and standardization in the numerical columns. Next, we train the model using linear regression, decision tree, and random forest algorithms, and compute RMSE and cross-validation score for each algorithm. Let's see the RMSE of each algorithm. As you can see, the RMSE of decision tree algorithm is 0.62, which is minimum among the 3 algorithms. You might think that the decision tree is the perfect model because it has the minimum RMSE, but how do we validate if the model generated by the decision tree algorithm is really a perfect model? This is where we use cross-validation. Let's see the mean root mean square error of 10-fold cross-validation. The mean RMSE score of 10-fold cross-validation in linear regression algorithm is 36.07, while the same is 69.68 and 47.44 in decision tree and random forest algorithms respectively. Here, we can see that the model generated by the decision tree algorithm is overfitting, as mean RMSE of 10-fold cross-validation is much higher than the RMSE on the training set. In fact, the decision tree model performed worse than the linear regression. Let's discard the decision tree algorithm. We can see RMSE of random forest in the training set is lower than RMSE of linear regression, but its mean RMSE in cross-validation is much higher than on the training set. It means that random forest is overfitting the training set. To solve this, we can either regularize the model or get a lot more training data. We will learn regularization later in this course. Let's select the random forest model now for hyperparameter tuning. Here, we are fine-tuning the hyperparameters. The model after hyperparameter tuning is the final model. Next, we calculate the root mean square error on the test data, and if we are happy with the results, then we deploy this model into the production. The root mean square error on the test set is 109.4. One important thing to note is during the model training process, we can combine the features and create our own custom features. If we think these features are good predictors of the label. For example, we can create a new feature, RH by wind, which contains the quotient of division of RH by wind. Hope you like this project and happy learning.